Would you be excited if I told you that we have some more brand new images from the James Webb Space Telescope, including the first ones ever from the coldest detector on board? I bet you would be, and that's the exact same reaction I had.
We're gonna give everybody an opportunity to concur, but...
Yep, I concur.
So let's see what's new from the most complex telescope ever built, and see how close we are to starting some science. The team behind the Webb telescope seemed to never stop. Just 4 or 5 weeks before this milestone, they finished aligning the segments of the huge 6.5 meter primary mirror. Just a couple of weeks after that, we saw the coldest instrument on board, called MIRI, reach its insanely cold operating temperature of around 7 Kelvin. And now, the alignment and calibration of every instrument on board is complete, and we have some cool images to confirm it. While the primary and secondary mirrors had already completed their initial alignment phases, the team then needed to align each of the 4 instruments on board Webb. This involved tiny movements of each of these detectors to perfectly focus the light as it entered each instrument. Since light travels a slightly different route to reach each of the detectors, the images can't be perfectly focused using just the primary and secondary mirrors, and small adjustments need to be made within the detectors too, and this is what's just been completed. NASA says these images confirm that all 4 instruments are perfectly calibrated, and to celebrate, they released this series of images to show us the full field of view, the universe according to Webb. For these images, Webb pointed at a small section of a small satellite galaxy near the Milky Way, called the Large Magellanic Cloud, giving us a dense sea of stars to look at and test Webb's focus. We see images from each of the detectors. Firstly, the near-infrared camera, NIRCam, which is a camera that looks at the shortest wavelengths of infrared light, closest to visible light, and will be used to look at the earliest stars and galaxies in the universe during their formation, as well as young stars in the Milky Way and distant Kuiper Belt objects near the orbit of Pluto. Secondly, we have the near-infrared spectrograph, NIRSpec, which looks at the same wavelengths of light as NIRCam, but instead of being a camera, it's a spectrograph. This means it disperses light, splitting it up into a spectrum. Analyzing this can then tell us about the physical properties of objects, such as their mass, temperature, and chemical composition. Despite being a spectrograph and not a camera, it can still take images like these ones for calibration and alignment purposes, but it won't do this for any of the scientific operations. You can also see dark stripes on the NIRSpec image, and these are because it's a spectrograph. It has shutters that open and shut to let through different wavelengths of light, and you can see their shadow on this image. Webb will be looking at some incredibly faint objects, such as the very first galaxies to form after the Big Bang. And as such, it needs to stare at them for hundreds of hours to get enough light for a spectrum to be taken. Given this, in order to maximize efficiency, NIRSpec is the first spectrograph in space that can observe 100 objects at the same time, allowing it to look at thousands of galaxies in just the first 5 years of Webb's operations. Thirdly, in this image, we have MIRI, the mid-infrared instrument, which looks at longer wavelength light. It's both a camera and a spectrograph, and it's the one that recently reached the coldest operating temperature out of all of the instruments, a chilly 7 Kelvin. It will study redshifted light from distant galaxies and stars, newly forming stars, and faint objects like comets. This is also the instrument with the widest field of view, so is most likely to produce the breathtaking vistas to rival and complement Hubble. Finally, we have the near-infrared imager and slitless spectrograph. See, no shutters in that image. Otherwise known as NIRISS. This is the instrument that's responsible for exoplanet exploration, and it will characterize exoplanets by looking into their atmospheres and looking for the planets as they transit their host stars. It can use 3 different modes to look at 3 different wavelengths of light. We also got an image from the Fine Guidance System, FGS, which is the guider that helps point the telescope so incredibly precisely. This won't generally take images for scientific purposes, but again, like NIRSpec, it can take images like this just for calibration. We can then look at these extra images with even more detail in them. It's so exciting. These are all so beautiful, and we can see some really cool things in the images. Firstly, just look at those diffraction spikes. If you want to know exactly what causes those, click on the card up here or the link in the video description. I have a video all about them. But it's basically due to the hexagonal shape of the mirror and the struts that hold up the secondary mirror. We can also see so many stars and galaxies in the backgrounds, providing us with more tantalizing tasters of what we can expect when Webb starts doing the real science. In fact, the sizes and positions of the images here are even representative of the relative arrangements of each of the instruments on Webb. each pointing at a slightly different part of the sky. The images let us assess both the sharpness of the telescope and also calibrate away the subtle image distortions in each instrument. All of these instruments are now working beyond even the most optimistic projections. All of the instruments are now diffraction limited, meaning the pictures they produce physically can't be any higher resolution, given the size of the telescope. This means we're ready to move on to the next stage of commissioning. And from now on, the only adjustments to the mirrors of the telescope will be tiny, periodic movements to the primary mirror segments. This commissioning is a 2-month process that involves trying each of the instruments out in all possible combinations of their lenses, masks, filters, and other equipment to make sure they work well in all situations. Each one will be configured and operated in various combinations to confirm they're ready to do science. Also, there'll be some ongoing telescope alignment. The actual craft will be pointed at various spots on the sky in such a way as to vary the amount of solar radiation on the scope and to check that the temperatures can remain stable in each instrument. They'll also keep taking observations every couple of days and make small movements on the primary mirror segments if needed, just in case anything shifts or changes over time. Well, that's pretty much all I have for you today. I hope you're as excited as I am about these brand new images. If you have any questions about Webb, then please let me know in the comments below. And subscribe on your way out if you had fun with this video. Until next time, stay safe team. I'll see you soon. Bye!